0.1. Right. All right, class. Let's see. No, let's try that again. There we go. So today is what, the 10th? Come on, Adobe. Okay. Just think about it a minute here. So the Zoom is upset. Oh, there we go. All right, so this is what, week 4? We need to finish 11:6 today. It says we have an exam next week. 13th is on a Thursday. You want to have your exam on a Wednesday or a Friday? I think last time you all said Friday. Just so you know, there are retests. All right, if you don't like your grade, you can take a retest. But the retest isn't via MyMathLab. The retest is a written test, so it's much harder. And you have to come in on a Saturday to take it, okay? And all the business calculus students that want to take the retest will meet in some big auditorium room on a Saturday. So all the retests are the Saturday after. So if you want it on Friday, that means you only have one day to study for the retest. See what I mean? Because if you have it on a Wednesday, you have more time. So that's the difference. Usually I have maybe 5 or 6 students out of 90 that'll take the retest because it is substantially more difficult. Some students do a little better, but most of them do about the same, I think. Right. So what do y'all want? Y'all want Wednesday or Friday? Friday? Figure Friday's better, then you have more time to study for the first test, right? And that gives us basically all next week then to just review for the test, right? We won't cover any new material, so figure that'll be better for y'all. All right, so we'll do that. So exam number 1 next Friday, right? It's in class, but it's done via MyMathLab. All right, so you have to come to class, make sure you have your laptop and all that, okay? And I will just sit here and watch you take an exam. Fun stuff. So today, we need to finish 11.6, which is all about the product rule, which says that if, how can I say this? If you have 2 functions that are multiplied together and you want to take the derivative of the product, it's going to be the derivative of one of them times the second function plus the derivative of the other function and the other one. I don't know how else to say that. All right. Or uv prime would be u prime v plus v prime u. You can write it either which way you want, okay, as long as you get the combination going on in there. And so product rule is how they like to say it. So y'all have the power rule now, right? The power rule is easy. Multiply by the exponent, subtract 1 from the exponent, right? Product rule. Calculus is so much easier than algebra. It's only like 3 or 4 rules and that's it. And here's the proof of it. It goes blah, 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 blah. I'm sure y'all don't care about the proof, but it works out. We'll eyeball it for a few seconds, just so that you believe me. So remember, the definition of the derivative was this limit. Y'all remember that? All right. So if you replace f with u times v, you get this big pile of stuff. And then you do a few little tricks, and it all comes down to u v prime plus v u prime. Okay, so there's your proof. So it just comes down to using the definition of what the derivative is with the limit, okay? And you can look at that in more detail if you want, but your goal in here is to be able to use this fact, okay? So let's look at some examples. Okay, so here's a function f, all right? Now the way you would typically do this is you would multiply this thing out, okay? You would distribute it. 2x times 3x squared is what, 6x cubed? And then 4 times 3 is 12x squared. So looking at that, you can automatically say, well, f prime by the power rule, 6 times 3 is 18. Subtract 1 from the exponent. 2 times 12 is 24. Subtract, boom, we know the derivative. That's from the power rule, right? So we're going to use an example where we could do it the easy way, right? But for now, just pretend like you couldn't multiply these out, okay? And let's use the product rule. So it would be the derivative of the first one times the second one plus the derivative of the second one times the first one. You can do it in whichever combination you want to do first, right? As long as you have the derivative of one times the other, and then you add and then switch, okay? All right, so the derivative of 2x to the 2x plus 4 is just 2. And then the derivative of 3x squared would be a 6x. 2 times 3 is 6. 6x times 2x is 12x squared. Then 6x times 4 is 24x. We combine like terms, we get 18x squared plus 24x. Same thing we got up here, okay? It proved to you that the product rule works. So here soon we're going to get functions where we couldn't multiply it out and do it the easy way, okay? But just to show that it works, okay? Gives you the same answer. Example. All right, here we go. Here's something. We could multiply this out, right, and use the power rule. Let's see, the square root of x times x squared. What is that? That's x to the, let's see, 2 is 4 halves, and another half would be 5 halves, right? And then we have minus 5 x to the first, that's 2 halves and another half, 3 halves. And then we would have 3x squared, and then minus 15x, right? If I just multiplied that out, the y prime using the power rule would be 5 halves x to the 3 halves. All right, 5 times 3 halves, that would be what, 15 halves? Subtract 1 from the exponent. 2 times 3 is 6, and then 15x just turns into a 15. We know that's what it is, but let's use the product rule. The y prime, see, it would be what? The derivative of the first one times the second one plus the derivative of the second one times the first one. Square root of x plus 3. All right, the derivative of this, right? The derivative of the square root of x is 1/2 x to the minus 1/2. So we got this guy. And now the derivative of this one, the derivative of x squared is 2x, the derivative of 5x is 5, and we have this guy right here. Now if we multiply this all out, let's see, this times this gives us a 1/2. Let's see, x squared, 2 is 4/2 minus a half, give us 3/2. Then minus 5/2, so we have x to the first minus a half, that would give us a half. Now this guy will multiply this dude out, so we have 2, so x to the, that would be 2/2 and another half is 3/2. That gives us 6x minus 5 square root of x, and then minus 15. If we combine our like terms, we have our 3/2 here. So 2 is 4/2, and another half would be 5/2. And now let's look at our square roots. We got this guy and this guy. Let's see, 5 is 10/2, right? So negative 10 and a negative 5 gives us negative 15/2. The square root of x. Why do I have this here? I need a plus or something here, don't I? Where did I get a 16x? It should have been a plus 6x, right? Right here. 2x times 3 is plus 6x. So we have our plus 6x and then a minus 15. It's the same thing that we got up here. Boop. All right. All right. So let's do these checkpoints here. Checkpoint 2. All right. So f prime for part A. If we use the product rule, we have the derivative of the first thing times the second plus the derivative of the second thing times the first. So the derivative of this using the power rule, 2 times 5 is 10. And then the derivative of 3x is just 3. We multiply this out, 10 times 3 is 30, x squared. So here we have 15x squared plus 18, 30, and 15 is 45x squared plus 18, okay? One way to do it, or you could have simply multiplied that out and used just the power rule, right? Could have done it the easy way. Look at B. All right, so G prime, we have the derivative of the first thing times the second thing plus the derivative of the second thing times the first thing. All right, we're just going to do this over and over again for the next 50 minutes. All right. The derivative of 8x is just 8. The derivative of this guy, let's see, the derivative of 4x squared would be an 8x. The derivative of 5x would be 5. And then we have this 8x here. All right, notice how parentheses, right? I think the biggest problem y'all, a lot of y'all are going to have is the algebra part, right? Not the calculus part. The calculus is easy. We have 2 rules so far. That's it. All right, so the derivative of this is this. And then we just want to multiply this dude out. 8 times 4 is 32. 8 times 5 is 40. 8 times 8 is 64. And then 8 times 5 is 40. Combining like terms. All right. What we got? We have 32x squared, 40 and 40 make 80, 64, 144x. All right. So try to follow along. Tell me if I make a mistake on my algebra or my arithmetic. All right, with all these brains in here, we shouldn't make any mistakes, right? All right. Or we could have multiplied this out. 8 times 4 is 32x cubed. 8 times 5 is 40x squared. So if I took the derivative like that, 3 times 32 is what, 96x squared. And then 2 times 4 is 80x. So obviously I did something wrong, right? Notice it was a lot easier to do it this way. Let's make sure I did it right. 8 times 4 is 32, right? And then you got an x cubed. 8 times 5 is 40x squared. So 3 times 32 is 96. Subtract 1 from the exponent. 2 times, so this is what we should have got. So notice this was like substantially more difficult. And clearly I did something wrong somewhere. So let's try this again, because we should be getting this, right? So it is the derivative of the first thing times the second thing plus the derivative of the second thing times the first thing. So the derivative of 8x is just 8. And the derivative of the second thing, the derivative of 4x squared would be 8x. The derivative of 5x is 5. 8 times 4 is 32. 8 times 5 is 40. 8 times 8 is 64. And 8 times 5 is 40. 32 and 64 give us 96. 40 and 40 give us 80. All right. So if you're doing an exam or something and they want you to they specifically say use the product rule. Okay, well, use the product rule. But to check your work, try doing it the easy way to compare your answer like I just did to make sure I got it right. Okay, if you have that option. All right, 6.3. All right, we could multiply this out. Let's do it the long way though. F prime, we have the derivative of the first thing times the second thing plus the derivative of the second thing times the first thing. So the derivative of x squared minus 3 is a 2x, right? Multiplying by the exponent, subtracting 1. And then we have times this other stuff. And then the derivative of this, power rule, right? This is x to the 1/2. So multiply by the exponent, subtract 1 from the exponent, and times the x squared minus 3. Right, so all we're doing is product rule, power rule, product rule, power rule. And now we multiply these out. Now the rest is just algebra. So this is 2 x to the first. That would be 2 halves and another half. Gives me 3 halves. And we got 10x. Now this one, 2 is 4 halves minus a half is 3 halves. And we have minus 3 over 2 x to the minus 1/2. Okay. Combining like terms, the C2 is 4 halves and another half. 4 halves, another half is 5 halves. And then we have our 10x and minus 3x to the minus 1/2. Okay. Assuming I didn't mess up my algebra. B. g prime. We have the derivative of the first thing times the second thing plus the derivative of the second thing times the first thing. So the derivative of this, by the power rule, this is x to the 1/2. We multiply by the exponent, subtract 1 from the exponent, times this 5x squared plus x. Now the derivative of this, power rule, 2 times 5 is 10. Subtract 1 from the exponent. The derivative of x is just 1. And then times this stuff. Did I hand out the sign-in sheet or didn't, did I? Did it? All right, cool. All right, so let's see. We need to multiply this stuff out. So let's make it pretty. So we have this times this, 5 over 2. 2 is 4/2 minus 1/2, 3/2. That one times that one, that gives us 1/2. X to the first power 1 is 2/2 minus 1/2, gives us 1/2. Right, that's a 1, not a prime. Now we'll FOIL this dude out. We have 10 x to the first, 1 is 2/2 and another 1/2. 2/2, yeah, gives us 3/2. We have 40x square root of x 4. Collecting like terms, let's see. 10 is the same as 20/2, so we have 20 and 5 gives us 25/2 x to the 3/2. Those are taken care of. Now our square roots here, I have 1 and 1/2. That gives me 3/2. And then we got the 40x and the 4. So any questions? Is it boring so far? Same thing over and over again? The hard part is just algebra? Okay. And again, every one of these we just did, we didn't have to use the product rule. We could have multiplied it out ahead of time and then just used the power rule, right? So we just did a whole lot of needless difficulty. But we will have functions where you can't multiply it out. Here is the quotient rule. This is harder to remember. All right. So if you have u v prime, it's going to be vu prime minus uv prime. Now this is wrong. U over v. There we go. Quotient rule, right? Over v squared. All right. So this one is more difficult to remember. Just remember the one on the bottom stays on the bottom and gets squared. All right. So, and then it's hard which one gets the minus sign, right? So the bottom one comes first. It's v, then the derivative of the top one, then subtract the top times the derivative of the bottom one and put that all over v squared. Okay, hard to remember, right? During the exam, there will be a formula sheet. I think I'll put it up here for y'all with the basic, because I don't want y'all to miss these problems because you can't remember which one gets the minus sign, right? But you're going to do this enough, where you're going to remember it. Okay, you'll use it a lot. I have to rememorize it every time I teach it. VU prime minus UV prime. All right, so it's y'all's job to make sure that I don't screw that up in the next few examples. VU prime minus UV prime. Okay. So let's look at this one. Okay. All right, so this one, it's like there is no other way to do this, is there? We can't divide these out, right? This would be like 2x over 4x plus 3 minus 1 over 4x plus 3. Unlike the last example where we could have just multiplied them out and just used the power rule, right? Done it the easy way. If we don't have that option anymore, we actually have to use the quotient rule. So the derivative is going to be, the thing on the bottom is going to be squared. So we need to start off with, what was it, VU prime? Start off with the thing on the bottom times the derivative of the thing on the top, then subtract. We need the derivative of the thing on the bottom times the thing on the top. All right, I might have wrote it a little different. Yeah, I put V prime U. That's the same thing as UV prime though, okay? As long as you get this minus in the right spot. Okay. So again, the thing on the bottom times the derivative of the thing on the top minus derivative of the thing on the bottom times the thing on the top. You can write these in any order right here, it doesn't matter. So now we just apply the algorithm. Now, here's the calculus. The derivative of 2x minus 1 is just 2. The derivative of 4x plus 3 is just 4. And we could square this out. I'm going to keep it like this instead of squaring it out in case I can get this thing to reduce. All right, maybe I can reduce the fraction. 2 times 4 is 8. 2 times 3 is 6. 4 times 2 is 8. Minus comes a plus. Okay, so let's see, those cancel. 6 plus 4 is 10. That's my answer, right? So you can see why I didn't square that out. There was a possibility I could end up with a 4x plus 3 on the top, and then I could reduce the fraction, right? But even though there isn't, I'd rather leave my answer like that. That's prettier than if I multiplied that out, okay? So don't waste your time doing unnecessary algebra. We only want to do as much algebra as we have to. And that's it. All right, here they're using the alternate notation, right? This is the same thing as saying prime, right? That's all that is. So we'll do it using their notation. So this thing is going to be the thing on the bottom squared, right? We're going to have the thing on the bottom times the derivative of the thing on the top minus the derivative of the thing on the bottom times the thing on the top. Okay, and again, this is just the same thing as saying prime. We're specifying exactly what variable, right? Sometimes you have to use this because, like, if there's x, y's, and z's in here, we don't know which variable you're taking the derivative with respect to if you just put prime. Okay. So let's see. We have 4x squared plus 1. The derivative of this, we need our parentheses, right? Because there's two things here. The derivative of x is 1. 2 times 2 is 4. Subtract 1 from the exponent. The derivative of this guy, we're going to need parentheses here. 2 times 4 is 8. The derivative of 1 is just 0. And maybe I didn't need parentheses. And then we got this guy, and this is all over 4x squared plus 1 squared. So now we just do the algebra. We have 4x squared minus 16x cubed plus 1 minus 4x minus 8x squared plus 16x cubed all over this. And let's combine like terms. Here's our x cubed, they go away. 4 minus 8, negative 4. So we got a minus 4x plus 1 all over 4x squared plus 1 squared. I don't know, but there's a possibility we could maybe factor that, but I don't think so. This thing has an x squared in it. Yeah, at that point, I'd leave it like that, right? We don't have to do any more algebra. We're focused on calculus in here. Okay? I mean, it'd be nice if we could just do this. Calculus is done, right? Done. But that would be kind of ugly, right? We should reduce things as much as we can. Like, what is the final answer? It depends on your aesthetics, really. What do you think is beautiful? Obviously, this is prettier than this, right? But from here to here, it's all algebra. We're here to learn calculus, right? Yeah, you're going to want to simplify your answer. I mean, on the MyMathLab, y'all have more experience with MyMathLab. I've honestly never worked a single problem in MyMathLab in my life. So if you have MyMathLab issues, you need to talk to one another, right? Always make yourself a study group in any class that you have. So I don't know what, I mean, when I was in school, everything was done on paper, you know? That was it. But yeah, you always want to simplify your answer as much as you possibly can. Okay. Let's look at A here. All right. We have F prime. It's going to be, we're going to have the thing on the bottom squared. And you know what? I'm going to end up writing that over and over again. So I'm going to copy that. I hated using paper. Once I started using this thing, I never used paper for 15 years. It made it really hard whenever I had to go in and take my qualifying exams for my PhD on paper. I was like, I can't copy, I can't paste. It was the most awkward thing in the world, you know? It was like, when I get into my automatic car, it's like, where is the clutch? I keep stomping on the brake. Yeah. All right, so we have, what is it? The thing on the bottom times the derivative of the thing on top minus the thing, what is it? The derivative of the thing on top times the thing on the bottom. No, I did it, but yeah, that's right. 3x plus 7. Yeah. The thing on the bottom, the derivative of the thing on top, and then subtract, and then switch a root key. All right, so that's awesome. We still have our 5x plus 8. The derivative of that is just 3. We have a minus. All right, this guy, the derivative of 5x plus 8 is just 5. 3x plus 7. Calculus is done. 3 times 5 is 15. 8 times 3 is 24. 5 times 3, and I've got to be careful here because we got a minus. Minus 5 times 3 is a minus 15x, and then a minus 5 times 7, right? Those are going to be the kind of mistakes that you're going to make, right? Algebra, the minus goes to both of these things. And now we collect like terms. Those cancel. 24 minus 35 is what? Negative 11, I think. Boom. Now let's do it again. All right, G prime. We're going to have the thing on the bottom squared. We have the thing on top times the derivative of the thing on the bottom minus the thing on the bottom times the derivative of the thing on top. So 2x plus 11. The derivative of 5x minus 1 is just 5. The derivative of 2x plus 11 is just 2. Now for the algebra, 10x plus 55. All right, we have a minus 10x minus minus 2. Those cancel. 57 over 5x minus 1 squared. Yeah. By the end of this semester, you should be really good at algebra. Okay. Algebra is just one of those pattern recognition things. You just have to keep doing it until. Did we do example 4? I don't remember. So yep. Just do it till the pattern recognition skills kick in, and then your algebra becomes a lot easier. You can see I still make tons of mistakes, but of course I'm doing it as fast as I possibly can because time is so limited in here, right? I was doing it for like my homework or something, I'd probably do it as fast as I could, but I'd double check it, verify it different way. All right, so this guy, if you can simplify this, try it, you know, like if this was a 7x minus 9 up here, I would be like, boom, screw that, I'm just gonna, you know, simplify first, right? So that's where your algebra comes in. Using the algebra to simplify stuff before you use your calculus saves you time. Here we can't do much, right? But what we could do is, because this is the product rule and then the quotient rule, we don't know how to do both of those at the same time yet. We don't have the chain rule. What you want to do is multiply this dude out first. This is 15x plus 3 minus 20x and minus 4x. Is that right? No, 20x squared minus 4x all over 7x minus 9. So let's we got a negative 20x squared. 15 minus 4 is 11. All right, so now that I've done that, now I can use the quotient rule, right? Because, well, I mean, we could do it the other way too. Let's take the derivative like this, and then we'll see what it would look like if we tried it the other way, right? So this way is going to be the faster way. We have thing on the bottom squared, right? Might need more room. All right, so we have the thing on the bottom times the derivative, the thing on top, minus the derivative of the thing on the bottom times the thing on top. Fine. Yeah. So we have this guy, the derivative of this dude. Okay, 2 times 20 is 40. The derivative of 11x is 11. All right, the derivative of that is just 7. And then we have times this stuff. All right. Multiplying all this stuff out. 7 times 4 is 28. 7 times 11 is 77. 9 times 4 is 36. 9 times 11 is 99. 7 times 2 is 14. 7 times 11 is 77. 7 times 3 is 21. Okay, combining like terms. 77 x's go away. Maybe. Yeah, 360. Thank you. So our x squareds here, that would be what, negative 140 x squared. 360. I guess it's just 360. 99 and 21 is 120 all over 7x minus 9 squared. All right. I don't know, maybe we might be able to factor that and reduce this. I don't know. Let's see, what can we pull out all these, right? They're all divisible by like 20, right? I pulled out a negative 20 on the top. Let's see, 20 times what? 7, all right? And then how many times does 20 go into 360? Half of 36 would be 18, right? And then 20 goes into 126 times. All right. I don't know. I don't see it. I don't see this factoring into that. So I wouldn't bother with this. Right? If it's not going to reduce, there's no point in going with it. So I don't know why I started way down there. That's one way to do it. That's probably the faster way. We could have done it this way. We could have been like, okay, fine, f prime. We have the thing on the bottom squared, right? We could have been like, okay, here's the thing on the, no, we need the derivative of the thing on the bottom. No, it's not. The thing on the bottom times the derivative of the thing on the top minus the thing on the top times the derivative of the thing on the bottom, right? We could have done it that way instead of multiplying this out. If you didn't, you could do it this way, but you'd have to use the product rule here, right? Inside of the quotient rule, y'all see that? Which is totally doable. It just becomes a big hassle, right? So yeah, here you would have to use the product rule. So it's a lot easier just to multiply it out first, okay? Does that make sense? Kinda? Right, okay. That's how they did it. They did the product rule inside of the quotient rule. See right here, that's the thing on the top, right? Fine. So we just multiply this thing out first, and then it's a lot easier. So yeah, they did that. We get the same answer. Okay, average cost. Finally getting to some business stuff here. All right, so this is something you need to know. This bar, that means average. So you have cost. Well, the average cost is going to be the cost divided by the number of items. The cost of however many items divided by the number of items, that should make sense as average. Like, how do you average anything? You take all of them, add them up, and divide by the number of them. The cost of all of them divided by the number of them. So you're going to see this. If you see this, you have to remember that's, put it over that. So like revenue, the average revenue would be your revenue over X, all right? So this is important. So you all know the word marginal, right? And now we have average. So we got three things going on. Let's say we have cost, all right? We'll have the average cost. We'll have the marginal cost, right? And we will have the average marginal cost. So you do both of them, okay? So remember the marginal cost, like if I said this is how much it would cost to make 101 of them if you've made, already made 100. Remember that last time? Okay. So what would this be? The average marginal cost, right? This tells you the average cost to make one more, okay? And we'll get to that, all right? But yeah, this is gonna be your marginal average. So be careful, right? This marginal average cost is this guy. So you have average, marginal, and average marginal, right? The math is a lot easier because you just apply these, right? So this would be C over X prime, okay? All right, so we don't need to do more derivatives, I don't think. Doing that over and over and over again. So there will be problems like this on the exam. This is the hardest part here. Just be real careful what it says here. Find the average cost per phone. All right, the average cost is C over X. So take this whole thing and divide it by X. So there's C, right? Dividing by X. Okay. So if I multiplied everything by this 1 over X here, let's see. I have to distribute. This is 50x squared plus 30x plus 4. And so if I multiply everything down here by x, I get x squared plus 2x. And then 8,000 over x. Most common mistake students are going to make is not divide by x, right? So this is C bar. So part B, they're going to ask for find the average cost per phone. Here we go, part B. Oh, I guess they're still sticking with average. If that's the average cost, find the average cost per phone of each of the following. All you do is plug, this is C of X, right? Just plug these numbers in. Y'all know how to do that, right? Just evaluate the function, that's it. Find the marginal average cost, okay? All right, marginal and average. So we need to take the derivative of C bar. So we need to take the derivative of this thing. Okay, let me see, read these questions carefully. There's marginal, there's average, and the marginal average. This is marginal average. So we take the derivative of this thing. So this is going to require, this is going to be the same thing as the derivative of this plus the derivative of this, right? We can bust that up, right? And then this guy, you have to use the quotient rule, right? We have everything on the bottom squared. This is really just x to the minus 1, right? So for this guy, we're just going to use the power rule. This guy, we have to use the quotient rule. Thing on the bottom squared. So it's the thing on the bottom times the derivative of the thing on top. Look at that. Minus thing on top times the derivative of the thing on the bottom. And I ran out of room. We still got to deal with this. So for this one, the power rule, we get a minus 80,000 x to the minus 2. So now we just have to apply our little derivatives here. Okay. For the sake of brevity, they've already worked it out for us. All right, so you had to apply quotient rule. Over here, it was just the power rule. Do your algebra, and then you get this. Again, this is C prime bar. All right, so when you're doing these problems, y'all know how to take derivatives now. Once you get that function, part B, they just want you to plug in some numbers into that function. All right, so here is our C prime bar. They want us to find the marginal average cost of 500 phones. So you plug 500 into there. And what does that mean? What is the marginal average cost, right? You know the marginal cost means that's the cost to make one more after you've made 500, right? And you know what average is. What is marginal average? At a production level of 500 phones, if an additional phone is produced, the average cost per phone, in this case, is decreased by 32 cents, right? So instead of it costing negative 32 cents, which would be the marginal, right? The marginal average, it's saying this is the average cost per phone for all of them, okay? All the way up to 500. All right, and at 1,000, the marginal average cost is negative 0.8. That means at a production level of 1,000 phones, if an additional phone is produced, the average cost per phone is decreased by approximately 8 cents per phone. All right, so it's a real subtle thing there to think about. That's something that you should read and think about over and over again. I have to relearn it every semester. It's like, what does that mean, right? If one more phone is produced, the average cost per phone is decreased by 8 cents per phone. Right? So you will get problems. Just make sure you read carefully what they're asking for. If it's average cost, make sure you divide by X. All right. If it's marginal cost, it's the C prime. Right. But if it's marginal average cost, right? Marginal average, that's divide by X and then take the derivative, right? That's where a lot of students will mess up. They won't divide by the X first. Easy to forget, okay? So you should have everything you need to do the homework for 11/6. We'll finish it up on Monday, but again, your homework is due by Monday, but I think y'all got enough of it. And then we will review Monday and Wednesday for your exam on Friday.